So let's take a moment to review what kind of information we can gather from a scatter plot. First of all, we can decide whether or not a strong, weak, or non-existent association exists between our two quantitative variables. If a relationship or association does exist, we can describe that as either a positive or negative association. And we want to look for both linear and non-linear trends. Our next step is to describe that association numerically. So we want to describe a statistic or talk about a statistic that measures the strength and direction of linear relationships. And the name of that statistic is the correlation coefficient. The symbol for the correlation coefficient is the variable r. And r is always a number that is in between plus and minus 1. The two extreme values of 1 and negative 1 represent a perfect association. An r of positive 1 is a perfect positive association, and an r of negative 1 is a perfect negative association. It is extremely important that we realize that we're only going to quote correlation coefficients if there is a linear relationship. They will not be used for non-linear relationships. So the next few slides gives us some examples. Here is a perfect positive association with a correlation coefficient of 1. A not so perfect but still strong positive linear association with a slightly smaller correlation coefficient of a positive 0.9. There is in fact an upward trend to this data, so there is a positive association, but it is weak, and as a result the correlation coefficient is smaller, closer to 0, and it is a 0.4. Here we have our perfect negative association with a correlation coefficient of negative 1. A strong negative association with a correlation coefficient that is negative but smaller than negative 1. It's a negative 0.9. A downward trend to the data, but it's weak, a weak negative association, a correlation coefficient of negative 0.4. Now check this out. In the way I see it, there is essentially no association. There is no positive trend, no negative trend, so our correlation will be close to 0. A correlation coefficient of 0 indicates no association between your studied variables. This is an important slide. There certainly is a trend to the data. The data goes up, reaches a peak, and then comes back down again. This is a trend, but it is not a linear trend. And if we were to fit a straight line to the data, our line would most likely be horizontal, and our correlation coefficient would turn out to be close to 0. When you finish viewing this video, I'd like you to go to this website and play the correlation guessing game. Now, here it comes. This is the bad news. The computational formula for the correlation coefficient is very nasty. It involves evaluating means, standard deviations, doing lots of subtractions and multiplications, and finally some adding. The good news is that in this course we're going to use StatCrunch to evaluate the correlation coefficient whenever we need to do that. So before we leave, let's look at a couple of concrete examples. Here we have data collected on automobiles of different weight and varying city miles per gallon. If we look at the scatter diagram for this data, where we put weight on the x-axis as the explanatory variable and city miles per gallon on the y-axis as the response variable, we certainly notice a downward trend. There seems to be a negative linear association. I'd like you to take a minute to estimate R. StatCrunch reports R to be a negative 0.816, which is rather close to -1, so that indicates there is in fact a strong negative association between weight and city miles per gallon, as evidenced from the scatter diagram. Now here is a very important example. Data was collected on the life expectancy and number of people sharing a TV in countries throughout the world. We're going to put number of people per TV on the x-axis as the explanatory variable and life expectancy on the y-axis as the response variable. There certainly does seem to be a definite negative trend to the data, a downward trend, and StatCrunch reports a correlation coefficient of approximately a negative 0.8, which indicates a strong negative association. The question becomes, how do we appropriately interpret that? I would suggest that the appropriate interpretation is simply to say that the number of people that share a TV is in fact associated with the average life expectancy of a country. What we want to shy away from is saying that the number of people who share a TV cause the life expectancy to be what it is. There is a vast difference between association and causation. Certainly shipping more TVs to countries with a low average life expectancy is not going to do anything to improve the life expectancy. There is a quantity of lurking variables such as the kind of health care in the country, the gross national product, and other things that are really behind or associated with both of these variables. This ends our video on the correlation coefficient.